Dear student, once again we are here to solve some question related to the first article, and the article is when we have two forces P and Q acting at an angle alpha, then their resultant is R, which is equal to square root of P square plus Q square plus 2PQ cos alpha. So here this video lecture is dependent on some question related to this, and here we have some numerical question. Recap is R is equal to square root of P square plus Q square plus 2PQ cos alpha, which I have already told you that when P and Q are two forces acting at an angle alpha, then their resultant is equal to R, and direction makes an angle phi, R makes an angle phi, then tan phi is equal to Q sin alpha over P plus Q cos alpha. P plus Q cos alpha. So let's start some question. It's my advice to all of you that I do all the sums, but please students, try it yourself. Take some help from this video, but try yourself to complete the exercise. So first question is, at what angle must forces of 8 kg and 3 kg be inclined in order that their resultant may be 7 kg? So first question is, we want to find angle. So first 4-5 question where we want to find angles only. So here what angle? Angle we want to find. One force is 8 and other force is 3 kg, and the resultant is R kg. So let alpha be the angle between 8 and 3 kg force, and 7 is the resultant. So we put in the formula. This is a simple one. 7 square is equal to R square is equal to P square plus Q square plus 2PQ cos alpha, and on simplification we got cos alpha is equal to minus 1 by 2. So minus 1 by 2 means it's a 90 plus theta. So in second quadrant cos is negative. So alpha is equal to 120 degree. Similarly, second question is, at what angle? Again we need to find angle. Force of magnitude P plus Q and P minus Q. One force is P plus Q and other force is P minus Q must act so that their resultant of magnitude is P square plus Q square 3Q square square root. So same question is there. Now the force, one force is P plus Q, other force is P minus Q, and the resultant is root P square plus 3Q square. Just we replace these value in the given result which we proved earlier, that is R square is equal to first force square plus second force square plus 2 into force 1 force 2 into cos of angle. And when we simplify it, we got cos alpha is equal to minus 1, which is again alpha is equal to 120 degree. Similarly, we have second part of the question where the resultant is R dash we want to find, and now angle is given 60 degree. So we put x cos alpha is equal to 60 degree and we got R dash. Now come to the third question. R and S are the magnitude of the resultant of two forces of magnitude P and Q acting at a point when the angle between the forces is 60 degree and 120 degree respectively. Show that R square plus S square is equal to 2P square plus Q square. Here R and S are the magnitude of the resultant of two forces. So we have two resultant, one resultant is R and other resultant is S. Two forces, that is P and Q, and twice angle. Two angle is there. One first angle is alpha, that is 60 degree, and second time the angle alpha is equal to 120 degree. So first, from first case when angle alpha is equal to 60 degree, we got R square is equal to P square plus Q square plus 2PQ cos 60 degree. Cos 60 degree is 120. 1 over 2, so R square is equal to P square plus Q square plus PQ. 2 and 2 cancel. Similarly, S square resultant is S when alpha is 120 degree. So alpha is 120 degree. We got cos 120 is minus 1. We got S square is equal to P square plus Q square minus PQ, and adding these two 1 and 2, we got r square is equal plus s square is equal to p square plus p square 2p square, q square plus q square 2q square, and this one cancel. So this is the third question. Now come to the fourth question. The resultant of two forces acting at an angle theta is r. So resultant and angle is given. When they act at angle pi by 2 minus theta, their resultant becomes r by 2, and their resultant becomes r by 3 when they act at an angle pi by 2 plus theta. Prove that theta is equal to this. Student, it's very simple question. First time angle is theta, second time angle is pi by 2 minus theta, and third time angle is pi by 2 plus theta. First time resultant is r, second time resultant is r by 2, third time resultant is r by 3, and we want to find theta. Just see. So first case, r square is equal to p square plus q square plus 2p cos theta. Second case, r by 2 square. Second time, r resultant is r by 2. P square plus q square plus 2pq cos angle is pi by 2 minus theta, and simplify we got this. Third time we have r is r by 3, so this is r by 3 square, p square plus q square plus 2pq cos, and now angle is 90 plus theta, so we put 90 plus theta. So simplify these three. When we simplify these three, adding second and third, second r square by 4 and third one is r square by 9. Adding these two, we got p square plus q square is equal to 13 r square by 72. Put this value in the first de which values put kar denge, and then we got p q cos theta is equal to 59 r square by 72. Putting value of p plus q from 4 in 2, we got r square by 4 is equal to this, and sin theta we got 2pq cos theta and sin theta. When we got 2pq cos theta and 2pq sin theta, on dividing these two we got tan theta, and tan theta is equal to 5 by 9, theta is equal to tan inverse 5 by 59. So this is our question. This is fourth question. Now come to the fifth one. The resultant of two forces P and Q acting on a particle is R. If one of the force is reversed means negative, the resultant is R dash. Show that R square plus R dash square is equal to this 2 into P square plus Q square. First case is R square is equal to P square plus Q square plus 2pq cos alpha. Second case is R dash square is equal to P square plus minus Q square plus 2p minus q into cos alpha, and when we add these two, r square plus r dash square, and we got simple result. Similarly, sixth question is there. Two forces P and Q act along intersecting line having a resultant R. If the force Q is reversed, again Q is minus Q in direction, and change in direction and change into R square minus P square by Q in magnitude, show that their resultant is still of magnitude r. Their resultant is still r. This is again a simple one. First case is p r square is equal to p square plus q square plus 2pq cos alpha. Now the resultant becomes r dash, and q is reversed, r square minus p square by q in magnitude, but in direction also in magnitude. So r dash square is equal to p square plus the reverse in direction and change in magnitude, and direction also it's reverse in direction. So we take negative as a minus r square minus p square by q whole square plus 2p into this. And when we simplify these two, we got that r dash square is nothing else. R dash square is nothing else. It's p square minus previous one. Let's see. This is r still r square is equal to r square, as q and q here q square cancel, p square and minus p square cancel, so r dash square is equal to r square. Now come to the next one. Next is the resultant of two forces each equal to p in magnitude acting at an angle alpha if the is of magnitude r and the resultant of P and 1 by 3R acting at right angle is of magnitude 2 by 3R. Find the value of R. So here in this question, forces are equal in magnitude acting at an angle alpha and magnitude is R. First case is this, and the resultant is P and 1 by 3R acting at right angle is of magnitude 2 by 3R. So we have two cases. The first case is when R is the resultant of two equal forces acting at a point, so R is equal to 2P cos alpha by 2. Student, it's very much easy. Just put P, R square is equal to P square plus Q square plus 2PQ cos alpha. Here P is equal to P, so you got this result. And secondly, when we have 2 by 3R is the resultant of force. Force is, one is P and other force is 1 by 3R acting at an angle 90. Again we use same formula. So R square is equal to P square plus Q square plus 2PQ cos alpha. But alpha is 90, so that term is 0. So R is here 2 by 3R and P is P and Q is 1 by 3R. So on simplification we got P is equal to 1 by root 3R. Now putting this value here, we got R is equal to 2 by into 1 by root 3R cos alpha. R cancel. So cos alpha is equal to root 3 by 2. Now come to the next question, and this question is a very important question. The resultant of two forces P, Q acting at a certain angle is X, and that of P and R acting at the same angle is also X. The resultant of Q and R again acting at the same angle is Y. Prove that P is equal to root X square plus QR is equal to QR into Q plus R over Q square plus R square minus Y square. Prove also that if P plus Q plus R is equal to 0, then X is equal to Y. So this question is important from examination point of view. The first part is the resultant of two forces P and Q acting at a certain angle is X, and that of P and R acting at a same angle is also X. And third condition is Q and R acting at a same angle is Y. So three conditions are there. So first condition, X square is equal to P square plus Q square plus 2PQ cos alpha. Second condition is X square is equal to P square plus R square plus 2P R cos alpha, and third condition is Y square is equal to Q square plus R square plus 2QR cos alpha. On subtracting first and second, we got Q square minus R square plus 2P and Q minus R cos alpha. So on simplification we got cos alpha is equal to minus Q plus R over 2P. Putting this value of cos alpha in second equation, this equation, and we got X is equal to, its values put kar deti hai, and we got X is equal to, and then we got P square is equal to X square plus QR, and P is equal to square root of X square plus QR. And when we put cos alpha is equal to in 3, and we got Y square is equal to Q square plus R square minus this, on simplification we got this, and P is equal to QR by R square, but P is equal to this, and when we put this value we got this required answer. Now come to the next one. Similarly the second part is also there. P plus Q R is equal to 0, so Q plus R is equal to minus P. Cos alpha is equal to minus P by 2P, so cos alpha is equal to 1 by 2. X square is equal to P square plus R square plus 2PR, and Y square is equal to, subtracting these two, and we got X is equal to Y. So student, the rest of the exercise I want you do at your own level. If any question, you have any problem, then we can discuss again. Thank you.